In this particular question, we've been told that the sum of two whole numbers is 8, and we must find the two numbers if the square of one number plus the cube of the other is a minimum. Well, we'll start with the first sentence. The sum of two whole numbers is 8. So we are dealing with two variables. I'm going to call them x and y, so I'm going to write y plus x is equal to 8. Could have written x plus y is equal to 8, doesn't make any difference. We know that the square of one number plus the cube of the other is a minimum. So I'll write a for amount, or I could use any variable I wanted. A is equal to y squared, the square of one number, plus x cubed, the cube of the other. Now, when you take a look at that equation, you'll notice that it has three variables, a, y, and x. So it's not a function. It's easier for us to visualize maxima and minima on functions. So what we'd like to do is take this equation, which has three variables, and make it into an equation that has only two variables, and hopefully it's a function. So we return back to our first equation, y plus x equals 8, and we rearrange such that we solve for y in terms of x, and we get that y is equal to 8 minus x. Now we can substitute this back into the other equation. We can substitute this 8 minus x in for y, so we end up with a is equal to, in brackets, 8 minus x squared plus x cubed. In the next line, all I've done is merely expanded that using my distributive property, and I get that a is equal to 64 minus 16x plus x squared plus x cubed. I'm now going to take the derivative of this with respect to x. So a prime is equal to negative 16 plus 2x plus 3x squared. Minima and maxima occur when our first derivative, a prime, is equal to 0. They also occur in some cases when our first derivative does not exist. But in this particular case, we'll just look at it equaling 0. So 0 is equal to 3x squared plus 2x minus 16. Now, I could solve this using the quadratic formula, but I noticed that it can be solved using decomposition. So 0 is equal to 3x plus or minus something times 3x plus or minus something, all divided by 3. This is a technique for doing decomposition. So what I have to now do is multiply my leading numerical coefficient 3 by my constant in the equation, negative 16, and I get negative 48. Then what I must do is find two numbers that multiply together to give me that negative 48, and those same two numbers have to add together to give me the coefficient of my middle term, which is 2. Well, the numbers are 8 and negative 6. I can now place these values into the expression. So I have 0 is equal to, in brackets, 3x plus 8 times 3x minus 6, all divided by 3. And what you'll notice is that the 3 divides evenly into that second binomial, the binomial 3x minus 6. So I end up with 0 is equal to 3x plus 8 multiplied by x minus 2. If the product of these two binomials is a 0, then one of those binomials, one of those factors, must be equal to 0. So 3x plus 8 equals 0, which when I solve gives me x equals negative 8/3, which I'm going to cross off because they told us right off the bat that our two numbers were whole numbers, and negative 8/3 is not a whole number. I've also got to consider that my factor x minus 2 possibly is equal to 0, and when I solve, I get x is equal to 2. Then I go about finding my corresponding y coordinate, which is 6. I found that by putting into the first equation we had, y plus x is equal to 8. Now, the only thing I have to check is if this is indeed the value of x which produces a minimum value for a. So I find a double prime, and it's 2 plus 6x, and I substitute in my value of x, which was 2, and I get an answer of 14. So what we can see here is that a double prime is indeed greater than 0, and that tells us that we are indeed dealing with a minimum. So the two numbers that we've been asked to find are 6 and 2, where 6 is the first number and 2 is the second number. We're going to try an alternate approach to this question now. The question being the sum of two whole numbers is 8. Find the two numbers if the square of one number plus the cube of the other is a minimum. This technique that we're going to use relies on implicit differentiation. You will find that most textbooks and most professors don't actually use this technique, but I'm going to show it to you anyways in case you do have one of those professors who do prefer this technique in your post-secondary education. We start the same way as we did as the other question. We write down the two equations. Y plus x is equal to 8, and a is equal to y squared plus x cubed. We're now going to differentiate both of these equations with respect to x. The reason we chose x is because both of the equations contain the variable x. We could have just as easily differentiated both of these equations with respect to y because both of the equations contain the variable y. So when I differentiate the first equation with respect to x, I end up with dy dx plus 1 equals 0. When I differentiate the second equation with respect to x, I end up with dA dx is equal to 2y dy dx plus 3x squared. Now I return to the left-hand side of the screen, and what I'm going to do is solve for dy. I do this by merely subtracting 1 from both sides of the equation. So dy dx is equal to negative 1. Now I return to the right-hand side of the screen. We know that the slope of the tangent line to a curve at a maximum is equal to 0. So dA dx is going to be equal to 0. That's going to be equal to 2y times dy dx, which we just worked out to be negative 1. So we substitute negative 1 in for dy dx, and we add to that the 3x squared. Now, if you look at that equation, it has two variables in it, y and x. Be nice if we were down to one variable so that we could solve for that one variable. We return to our original equation on the left-hand side, which is y plus x equals 8, and we rearrange the equation such that we solve for y in terms of x. We do this by merely subtracting x from both sides of the equation. So y is equal to 8 minus x. I can now substitute this into the equation on the right. So we now have 0 is equal to negative 2 times, in brackets, 8 minus x, and then we add to that 3x squared. When we expand this using our distributive property, we note that we end up with a quadratic. The quadratic is 0 is equal to 3x squared plus 2x minus 16. This can be factored using decomposition, which we did in the previous example or previous method. So I'm just going to write the factors down, which those factors being 3x plus 8 and x minus 2. And then we can go about solving for x. X is either going to equal negative 8/3, which we ignore because that's not a whole number. And then we also solve for x and end up with x is equal to 2, which is a whole number. We can go back and solve for the corresponding y, which is 6. So we now know that our first number is 6 and the second number is 2.